What if I told you that the invisible engine powering the American economy, the one handling your bank transfers, your airline tickets, and your insurance claims, doesn't run on the cloud you think it does? We hear the names constantly: Amazon Web Services, Microsoft Azure, Google Cloud. They are the titans, the undisputed kings of the digital world, powering everything from your Netflix binge to your startup's new app. Seems like they've conquered everything. And yet, 90% of the world's credit card transactions are processed on systems that are the direct ancestors of a different kind of cloud. 10 out of the 10 largest banks in the world, the very pillars of global finance, rely heavily on this platform. The same goes for 8 of the 10 largest airlines. These are not flashy tech startups. These are the bedrock institutions of our country, organizations where a single minute of downtime can cost millions of dollars and shatter decades of trust. So why would these multi-billion-dollar American giants, with the smartest engineers and the biggest budgets, deliberately choose a path that isn't AWS, Azure, or Google for their most critical operations? What do they know that the rest of the world doesn't? The answer is one of the biggest and most important stories in modern technology, and it's hiding in plain sight. It's called IBM Cloud, and understanding why these corporate giants bet their entire business on it will fundamentally change how you see the digital world. This isn't just a video for tech nerds. If you work in any major American industry, from finance to healthcare, you'll discover the hidden technological forces shaping your company's future and your career. If you're an investor or business owner, you'll learn a masterclass in strategic decision-making, weighing innovation against the brutal realities of risk, security, and regulation. And if you're just curious, you're about to get a backstage pass to see how the real economy, the one that can't afford to fail, actually works. We're going to pull back the curtain on the quiet giant of the cloud wars. To understand the why behind IBM Cloud, you first have to erase your current definition of the cloud. For most of us, the cloud is about agility, scalability, and cost-effectiveness. It's for hosting a website that can handle a sudden spike in traffic, for storing our family photos, or for running a new software application. And for those things, the big three are fantastic. They are the undisputed champions of what we call general-purpose cloud computing. But there's another world out there. A world of what engineers call mission-critical workloads. This isn't about hosting a popular blog. This is the air traffic control system for the entire Eastern Seaboard. This is the central transaction ledger for a bank with 50 million customers. This is the electronic health record database for a massive hospital network. These are systems of record that have been running, in some cases, for 40 years. They are complex, they are incredibly secure, and they are woven into the very fabric of the company. For these workloads, the number one priority isn't how cheap can we get it, or how fast can we spin up 1,000 new servers. The number 1, 2, and 3 priorities are reliability, security, and compliance. The system cannot go down. Not for a minute. Not for a second. A breach isn't just an embarrassing headline. It's a threat to the national financial system. Failure isn't an option. This is where the story of IBM begins to make sense. For over a century, IBM, or Big Blue, wasn't a software company in the way we think of Microsoft or a consumer data company like Google. IBM was in the business of building digital fortresses. They built the mainframes, those legendary room-sized computers that banks, governments, and airlines used to build their empires. These machines were, and still are, masterpieces of engineering, capable of processing billions of transactions a day with a level of reliability that makes modern servers look like toys. So when the cloud revolution started, these massive corporations faced a terrifying dilemma. On one hand, they had the shiny new promise of the cloud: flexibility, data analytics, artificial intelligence. On the other hand, they had their mainframes, these old, powerful, incredibly reliable systems that were the beating heart of their business. They couldn't just throw away the heart. Ripping out a 40-year-old banking core and replacing it with a brand new cloud-native system would be like performing open heart surgery on a marathon runner in the middle of a race. The risk was astronomical. Amazon, Google, and Microsoft essentially came to them and said, "Move your stuff over to our brand new house. It's amazing, it's modern, and we'll help you rebuild everything." But IBM came with a completely different proposal. They said, "We understand that your old house is a fortress that has kept you safe for decades. We built it. So don't move. We'll build a bridge. We will connect your existing, untouchable systems to the modern cloud. You get the best of both worlds. The rock-solid security and reliability of your core systems, plus all the new capabilities of the cloud." This idea is called hybrid cloud, and it is the absolute core of IBM's entire strategy. It's not an either slash or proposition, it's a both slash and solution. Think of it like restoring a classic American muscle car. You have this beautiful, powerful, irreplaceable V8 engine. You don't rip it out and replace it with a generic electric motor. That would destroy its soul. Instead, you keep that magnificent engine but you augment it. You add modern fuel injection, a new digital dashboard, a state-of-the-art sound system and GPS. You seamlessly blend the best of the old with the power of the new. IBM Cloud is the master mechanic that allows these giant corporations to do exactly that with their technology. This hybrid approach is why when you look at who uses IBM Cloud, it reads like a who's who of the industrial and financial backbone of the United States. It's American Airlines, managing the unbelievable complexity of their flight operations. It's Bank of America, securing trillions of dollars in financial assets. It's major healthcare providers who are legally bound by HIPAA regulations to protect patient data, with an almost paranoid level of security. These companies aren't choosing IBM Cloud because it's the trendiest option. They're choosing it because IBM understands their world. A world of intense regulation, of complex legacy systems, and of zero tolerance for failure. While other cloud providers were born on the internet, focused on web-scale applications, IBM's cloud was forged in the high-stakes world of enterprise computing. It speaks the language of compliance, of mainframe integration, and of industrial-grade security. So we've established the who, the titans of industry, and the fundamental what. This concept of a hybrid cloud built for mission-critical jobs. But the how is where the story gets truly fascinating. How did IBM actually build a cloud platform specifically engineered for these industrial giants? What specific technologies make it so different from the Amazon or Google Cloud you might already be familiar with? The answer involves a powerful concept called bare metal, a deep integration with a technology you've probably heard of called Red Hat, and a focus on security that goes far beyond what most companies could even imagine. It's a completely different philosophy on how a cloud should be built, from the silicon chip all the way up to the software. So let's break down that philosophy because it's the key to everything. To understand IBM Cloud, you first have to understand the world that most massive American companies actually live in. It's not the neat, tidy, born-in-the-cloud world of a Silicon Valley startup. It's a messy, complicated, and incredibly valuable world built over decades. Think about a company like American Airlines or Bank of America. They didn't start in 2010. They have layers of technology built up over 50, 60, even 70 years. Deep in their data centers, they have systems, mainframes that are the bedrock of their business. These aren't dusty relics. They are bulletproof workhorses that process trillions of dollars in transactions or manage millions of flight reservations with a level of reliability that makes modern systems look fragile. The idea that a company like that could just turn those systems off and move everything to Amazon or Google's public cloud in one go. It's a fantasy. The risk is astronomical. The cost would be crippling. And in many cases, due to government regulations around data privacy and security, it's literally illegal. This is the central problem that IBM set out to solve. While other cloud providers were essentially saying, move out of your old house and come live in our brand new apartment building, IBM came along and said, we love your house. The foundation is solid. Let's just build a state-of-the-art extension and connect it seamlessly to everything you already have. This is the core idea of hybrid cloud. It's not a compromise. It's a recognition of reality. It means a company can keep its most critical, sensitive data right where it is, on its own private servers, behind its own firewalls, under its complete control. But it can also tap into the incredible power and flexibility of the public cloud for new applications, for massive data analysis, for developing new customer-facing apps. The hybrid model connects these two worlds. It creates a bridge, allowing data and applications to flow securely between the company's private data center and the public cloud. They get the best of both worlds: the rock-solid security and control of their own infrastructure, plus the scalability and innovation of a public cloud. But how do you build that bridge? This is where the game-changing $34 billion acquisition of Red Hat comes in. Imagine you have a system built in the 1990s, another one built on Microsoft servers in the 2000s, and you want to connect them to a new application running on Google Cloud and another on Amazon Web Services. They all speak different languages. They have different operating systems, different networking rules, different APIs. Trying to get them to work together is a nightmare. It's like trying to plug an American appliance into a European socket while using a Japanese instruction manual. It's a mess of expensive, custom-built adapters and translators that are brittle and break all the time. Red Hat OpenShift is the universal translator. It's the master key. It's a layer of software, a platform that can be installed anywhere. On an old server in a company's basement, on a brand new IBM Power server, inside Amazon's cloud, inside Microsoft's cloud. It creates a single, consistent environment for developers to build and run applications. So now, a developer at a major bank can build a new mobile banking feature one time, and that feature can run identically wherever the bank needs it to, on their private cloud for maximum security during the login process, and then it can scale out to the public cloud to handle a massive surge of users checking their balances on payday. The underlying hardware and the specific cloud provider become irrelevant. This is a concept called containerization with Kubernetes as the engine, but the business implication is simple and profound: freedom. Freedom from being locked into a single cloud vendor. This isn't just a theoretical advantage, it's a strategic imperative for large corporations. The biggest fear of any chief technology officer is vendor lock-in. If you build your entire company using Amazon's proprietary tools, you are stuck with Amazon. If they raise their prices, you pay. If their service has an outage, your business goes down. If they launch a product that competes with you, well, that's awkward. By building on the open source foundation of Red Hat OpenShift, IBM is giving these companies an escape hatch. It's like building your house with standard-sized bricks that you can buy from any hardware store, instead of custom-made, weirdly shaped bricks that only one company in the world sells. This gives negotiating power back to the companies. They can run their workloads wherever it's cheapest, wherever it's most secure, or wherever it performs best. They can have a multi-cloud strategy, playing the giants off against each other. Let's make this real. Think of a healthcare provider in the United States, like CVS Health or United Health Group. They are bound by incredibly strict HIPAA regulations. Patient data is some of the most sensitive information on the planet. They simply cannot put raw patient records onto a standard public cloud server, where they don't have ultimate physical control. So, their core patient database, the system of record, stays on-premise, probably on an IBM system designed for extreme security. But they also want to build a new AI-powered tool for doctors that can analyze anonymized X-rays to spot signs of disease earlier. That kind of AI model requires immense, burstable computing power that is perfect for the public cloud. Using the IBM hybrid cloud model, they can do both. The patient data stays safe and sound in their private data center. A carefully scrubbed, anonymized version of that data is securely sent to the IBM public cloud. There, it can spin up thousands of powerful processors to train the AI model, a task that would be prohibitively expensive to do with their own hardware. Once the AI model is trained, it can be deployed anywhere via OpenShift, maybe on smaller servers in individual hospitals, so the analysis happens instantly right beside the doctor. The hybrid approach makes this possible. It allows them to innovate at the speed of a startup, while maintaining the security and compliance of a 100-year-old institution. This strategy also addresses a fundamental law of physics that often gets ignored in the cloud conversation: data gravity. Data has mass. Not physical mass, but a kind of inertia. A company that has accumulated 50 petabytes of data over 30 years can't just easily move it. The sheer time and cost to transfer that much information is one thing, but all the applications and business processes that depend on that data being right there are another. It's like trying to move the sun instead of just moving the planets. IBM's approach respects data gravity. It says, let's bring the computing to your data, rather than force you to go through the pain of moving your data to the computing. This is why you see IBM building out cloud capabilities on the edge, in factories, in retail stores, and hospitals, so that data can be processed right where it's created, without a long and risky trip to a distant data center. For a self-driving car that needs to make a decision in a millisecond, that's not a luxury. It's a life or death requirement. That's the hybrid edge. It's a completely different way of thinking about what the cloud even is. It's not a single place. It's a distributed network that stretches from a company's own server rack all the way to a global public network. So when major US companies choose IBM Cloud, they're not just buying server space. They are buying a strategy. They are buying a bridge to the future that doesn't require them to bulldoze their past. They are buying flexibility, control, and freedom from being locked into a single ecosystem. This hybrid platform, powered by Red Hat, is the foundation. It's the stage. But what truly sets IBM apart are the services they build on top of it. We're talking about security so tight it's trusted with the world's most sensitive financial and government data, and access to technologies that feel like they're straight out of science fiction. Let's start with the technology that put IBM's modern AI on the map for millions of Americans: You might remember it. The year is 2011. The stage is set for one of the most watched game shows in history, Jeopardy! On one side, you have Ken Jennings and Brad Rutter, the two greatest human players the game has ever seen, Titans. And on the other side is a computer, a machine named Watson. This wasn't just about trivia. This was a landmark test of artificial intelligence. Jeopardy! Isn't a simple search engine problem. The clues are filled with puns, metaphors, and subtle contexts that computers historically found impossible to understand. A clue like, the first national park east of the Mississippi, it's adorable, requires a machine to understand the pun on Acadia. For a human, it's a clever play on words. For a computer, it's a nightmare of ambiguity. Yet, Watson didn't just compete. It dominated. It systematically dismantled the greatest players of all time. But the real victory wasn't the prize money. The real victory was what it represented. Watson proved it could understand natural human language, with all its messiness and nuance, and reason through complex information at a superhuman speed. That Jeopardy! Winning technology wasn't just a party trick. It was the foundation for a suite of powerful AI tools that are now a core part of the IBM Cloud platform. Today, that same core intelligence has been productized into services that major companies use to solve real-world problems. Think about it. What is one of the biggest frustrations you have when dealing with a large company? It's probably customer service, right? You call a number, you get stuck in an automated phone tree from hell, pressing 1 for this, 2 for that, desperately trying to reach a human. IBM's Watson Assistant changes that game. Companies can use it to build chatbots and virtual agents that are actually helpful. They can understand what you're asking, even if you don't use the perfect keywords. They can access your account information securely, answer complex questions, and solve your problem in seconds. And if they can't, they can route you to the exact right human agent who already has all your information. For a massive US bank or airline, this isn't just a nice to have. It's a revolution. It frees up human agents to deal with the most difficult cases, while dramatically improving the customer experience for everyone else. Or take another service, Watson Discovery. Imagine you're a doctor at a major hospital. A patient comes in with a rare set of symptoms. You could spend days, even weeks, manually sifting through thousands of medical journals, research papers, and patient histories trying to find a similar case. Or you could use Watson Discovery. This AI can read and understand millions of documents, from dense medical text to doctors' handwritten notes, in a matter of minutes. It can identify patterns, connect symptoms to rare diseases, and surface the most relevant research to help a doctor make a life-saving diagnosis. It's not replacing the doctor. It's giving the doctor a superpower. This is the kind of value we're talking about. It's not just about storing data. It's about understanding it. And when you're dealing with AI, you're dealing with data. Often the most sensitive data a company has. Which brings us back to that other pillar we mentioned, security. IBM's reputation was built on being the trusted steward of data for the world's most important institutions. Their mainframe computers for decades have been the bedrock of the global financial system. They process something like 90% of all credit card transactions. When you swipe your card, there's a very good chance an IBM system is involved somewhere down the line. That legacy of trust is baked into the DNA of IBM Cloud. They know that for a bank, an insurance company, or a government agency, a data breach isn't just an inconvenience. It's an existential threat. So they've engineered their cloud with a level of security that borders on paranoid. They are pioneers in something called confidential computing. Let me explain what that means because it's a game changer. On a typical cloud platform, your data is encrypted when it's sitting on a hard drive. We call that at rest. And it's encrypted when it's moving across the network. We call that in transit. But when the data is actually being used by an application, when the computer is processing it, it has to be decrypted. It's in memory in the clear. And that moment, that tiny fraction of a second, is a window of vulnerability. For most applications, that's an acceptable risk. But what if you're processing the transaction data for the entire US stock market? Or analyzing classified government intelligence? Or handling the private healthcare records of millions of Americans? That tiny window becomes a gaping vulnerability. IBM's confidential computing, through services like their HyperProtect cloud services, slams that window shut. They've created a sort of digital Fort Knox. Using specialized hardware, they create a secure enclave where your data remains encrypted, even while it's being processed. Think of it like a sealed, opaque box. The data goes in, the application runs on it inside the box, and the answer comes out. But no one, not a hacker, not a rogue employee, not even IBM themselves, can peek inside the box and see the raw data. It is a level of end-to-end data protection that is simply unmatched. This is why companies in the most highly regulated industries on Earth, from banking to healthcare, look to IBM. They need that absolute, verifiable assurance that their most critical data is untouchable. So you have world-class AI to understand your data, and you have world-class security to protect it. But what about the problems that are so massive, so complex, that even the fastest supercomputers and the smartest AI in the world today can't solve them? What about the next frontier? This is where we step from the cutting edge into what truly feels like science fiction. Quantum computing. For the last 70 years, all of computing has been based on the bit. A 1 or a 0. On or off. It's a simple, reliable light switch. And we've just gotten incredibly good at packing billions of these tiny light switches onto a single chip. But some problems in nature aren't binary. They're not just on or off. Think about developing a new drug. You need to simulate how a complex molecule will interact with the proteins in the human body. That molecule can twist and fold in a near infinite number of ways. Trying to model that with ones and zeros is like trying to paint the Mona Lisa with a single black crayon. You can get a rough approximation, but you'll never capture the true complexity. A quantum computer doesn't use bits. It uses qubits. A qubit, thanks to the bizarre laws of quantum mechanics, can be a 1, a 0, or both at the same time. It's not a light switch. It's a dimmer switch that can be at any position, and can even be at multiple positions simultaneously. This ability, called superposition, along with another quantum phenomenon called entanglement, allows quantum computers to explore a vast number of possibilities all at once. The potential is staggering. With quantum computers, we could design new materials for batteries that hold a charge for weeks. We could create new catalysts to pull carbon out of the atmosphere. We could develop financial models that predict market crashes with stunning accuracy. These are the kinds of problems that are literally impossible for our current computers to solve, no matter how powerful they get. They are computationally intractable. And here's the kicker. This isn't just a theory in an IBM research lab. IBM was the first company to put a quantum computer on the cloud, making it accessible to anyone. Major US companies like ExxonMobil, JP Morgan Chase, and Boeing aren't waiting for the future to arrive. They are actively using IBM's quantum systems today through the cloud, running experiments, building expertise, and racing to be the first to achieve a quantum breakthrough in their respective industries. This is the ultimate differentiator. When a major US enterprise chooses IBM Cloud, they're not just renting servers for today's needs. They're buying a ticket to the future. They're gaining access to a portfolio of technologies, from language understanding AI to impenetrable data security to the dawn of quantum computing, that are designed to solve the biggest, hardest, and most important challenges they face. It's a platform built not just for running a business, but for reinventing it entirely. So how do you reinvent a company that's been around for 100 years? A company with systems so critical, they're literally the bedrock of our economy? You don't do it by throwing everything away and starting from scratch. That's a fantasy. You do it by building a bridge between the past and the future. And this is arguably the single most important concept to understand about IBM Cloud, and why it's so fundamentally different from its competitors. You see, in the early days of the cloud, the story was simple. Ditch your expensive, clunky data centers, move all your applications to our servers, and you'll save a fortune. It was a powerful marketing message. And for a brand new startup with no legacy, it made perfect sense. But for a Fortune 500 company, for a major US bank, an airline, a healthcare provider, or an insurance giant, it was a non-starter. And the reason comes down to a concept you could call data gravity. Think about it. A company like American Airlines doesn't just have a website. It has a reservation system, a global logistics network, a flight scheduling platform, and a frequent flyer database with decades of history. These systems are interconnected in a web of staggering complexity. They're not just applications. They are the digital central nervous system of the entire operation. The data for these systems, the core transaction records, can't just be casually uploaded to a public cloud server in Virginia. There are immense regulatory hurdles. The US government, financial regulators, and international bodies have strict rules about where sensitive customer and operational data can live and who can access it. Furthermore, there's the issue of performance. An application processing millions of credit card swipes a minute needs to talk to its database with almost zero delay. We're talking microseconds. If that database is on a server in your own building, that's possible. If it's hundreds of miles away in a public cloud data center, that added latency, that tiny fraction of a second delay, could be catastrophic at scale. The data has gravity, pulls the applications that need it close. Moving the data is so difficult, so risky, and so expensive, it's often easier to move the computing to the data, not the other way around. This is the messy, complicated reality that most cloud providers initially ignored. They were selling a one-way ticket to a new world, but their biggest potential customers were tethered to the old one by unbreakable chains of regulation, performance, and security. This is where IBM saw not a problem but its single greatest opportunity. Their entire cloud strategy is built around this reality. They didn't say, "Move everything to us." They said, "Let's connect everything you already have, wherever it is, and make it all work together as one seamless platform." This is the essence of hybrid cloud. It's the idea that a company's digital infrastructure isn't going to be in just one place. It will be a mix, a hybrid of different environments. Some applications will run on their own private servers, inside their own data centers, for maximum security and control. Some will run on the IBM public cloud to take advantage of its global scale and specialized AI services. And some might even run on other clouds like Amazon Web Services or Microsoft Azure, because a specific team needs a tool that only exists there. For years, this was the nightmare of every chief technology officer. Managing this sprawling, disconnected mess was a technical and financial black hole. Each cloud was its own walled garden, speaking its own language, with its own unique set of tools. Getting them to work together was a heroic effort of custom coding and brittle integrations that would break at the slightest change. It was like having a team where one person only speaks English, another only speaks Mandarin, and a third only speaks code. You'd spend all your time translating instead of actually getting work done. IBM's solution was to create a universal translator, and that translator is Red Hat OpenShift. When IBM spent $34 billion to acquire the software company Red Hat in 2019, it was the biggest software acquisition in history at the time. Wall Street was stunned, but IBM wasn't buying a company. They were buying the key to unlocking the hybrid cloud. So what is OpenShift? In the simplest terms, it's a software platform that lets you build, deploy, and manage applications in exactly the same way, no matter where they are running. Whether it's on an IBM mainframe in a basement in New York, on the IBM public cloud, on an Amazon server, or even on a small edge computer in a factory in Ohio, OpenShift creates a consistent layer over all of it. It's like a universal operating system for a company's entire computing landscape. It achieves this magic using two core technologies, containers and Kubernetes. Now, stay with me because understanding this is key. For decades, if you wanted to run an application, you needed a whole server with its own operating system. It was like wanting to ship a bicycle, but being forced to rent an entire 18-wheeler truck to do it. It was wasteful and inefficient. Containers changed that. A container is like a standardized, lightweight box. You package your application and everything it needs to run, all the code, all the libraries, inside this single self-contained box. Now, you can ship that box anywhere, and it will run identically. It's like putting the bicycle in a standard FedEx box. It doesn't matter what kind of truck picks it up. The box protects what's inside and ensures it arrives ready to go. But now you have a new problem. A large company doesn't have one box. It has thousands, tens of thousands. These containers need to be managed. You need to tell them where to go, how many copies to run, how to talk to each other, and what to do if one of them breaks. Doing this manually would be impossible. That's where Kubernetes comes in. Kubernetes is the logistics manager for your containers. It's the conductor of the orchestra, the air traffic controller of your applications. It's an open source system, originally designed by Google, that automates the deployment, scaling, and management of these containerized applications. Red Hat took this powerful but complex technology, Kubernetes, and built OpenShift on top of it, making it secure, supported, and easy to use for large enterprises. So now, a developer at a major bank can build an application inside a container on their laptop. That exact same container can then be deployed by OpenShift to the bank's private, on-premise servers for testing. Once approved with a single command, OpenShift can deploy hundreds of copies of that same container to the public cloud to handle millions of users, automatically scaling up during peak hours and scaling down at night to save money. The developer doesn't need to know or care where it's running. The security team can apply one set of rules that OpenShift enforces everywhere. The operations team has a single dashboard to see everything. It turns the chaotic, multi-platform mess into a single, unified, manageable factory for building and running software. This is the power of a true hybrid cloud platform. It doesn't force a choice. It provides a bridge. It allows a company to keep its crown jewels, its most sensitive data and critical systems, safe and sound where they've always been, while simultaneously building new, modern, AI-powered applications in the cloud, and having them work together as if they were sitting side by side. It's about modernizing from the inside out, not dynamiting the foundations. And this foundational strategy is what enables everything else we're about to explore, from IBM's approach to data and AI to the very fabric of their security. And at the heart of that strategy lies a fundamental, almost contrarian belief about the modern digital world. For the last decade, we've been told that the future is all about data. That data is the new oil. And that's true. But what they don't often tell you is where the most valuable oil is actually located. It's not in the new shiny data wells being drilled every day on the public internet, the social media posts, the search queries, the streaming habits. That's the light, sweet crude. It's valuable, sure, but it's not what powers the engine of the global economy. No, the real stuff, the heavy, dense, energy-rich stuff, is somewhere else entirely. It's estimated that around 80% of the world's enterprise data is not on the public cloud. It's locked away behind corporate firewalls, inside private data centers, on systems that have been running non-stop for decades. This isn't just data. It's the operational memory of our civilization. It's every credit card transaction you've ever made. It's the reservation system for every major airline. It's the clinical trial data for new medicines. It's the power grid control systems. It is the mission-critical, can-never-go-down, life-or-death information that makes modern society function. And for years, this created a massive problem for companies wanting to innovate with AI. The dream was to apply powerful machine learning models to this treasure trove of data. The reality was a nightmare. Imagine you're a major US bank. Your transaction history for the last 40 years, petabytes of it, lives on an IBM Z mainframe. This system is a fortress. It's incredibly secure, unbelievably reliable, and processes thousands of transactions per second without breaking a sweat. Now, your brilliant data science team wants to build an AI to detect fraudulent transactions in real time. The public cloud providers come knocking and say, "Great, just move all that sensitive financial data over to our cloud, and you can use our AI tools." This is where the record scratches. First, the sheer physics of it is staggering. Moving petabytes of data is slow and astronomically expensive. Second, it's a security and compliance black hole. You're taking the company's most valuable asset, the data that regulators like the SEC are watching like a hawk, and moving it outside your fortress. You have to create new security protocols, new compliance checks. You're effectively doubling your risk surface. And third, you're creating a copy. Now you have two sources of truth. The live data is still on the mainframe, while your AI is working on a stale, copied version in the cloud. By the time your model finds a fraudulent pattern, the crime has already happened. This is the concept of data gravity. Data, like a planet, has mass. And the more of it you have in one place, the harder it is to move, and the more it tends to attract applications and services to it. For decades, the industry's answer was, defy gravity. Spend millions to duplicate your data and move the copies to the cloud. IBM looked at this and said, "That's insane. You're fighting physics." Their solution, enabled by that hybrid cloud foundation we just talked about, was the complete opposite. Don't move the data to the AI, move the AI to the data. This is a profoundly different way of thinking. Instead of forcing a bank to uproot its most critical systems, IBM provides the tools to run the most advanced open-source AI models right where the data is born and lives, on the mainframe in the private data center at the edge of the network. Because Red Hat OpenShift can run anywhere, it means a containerized AI application can be deployed consistently, whether it's on IBM Cloud, AWS, or an IBM Z system sitting in a basement in Delaware. This is the entire philosophy behind their AI and data platform, called Watson. It's not a single monolithic AI like you might think. It's a toolkit designed for this hybrid reality. It has three main parts. There's WatsonX.ai, which is the studio for building, training, and deploying AI models, including the latest generative AI and foundation models. Then there's Watsons.data, which is what's known as a data lakehouse. Think of it as a way to store and analyze massive amounts of data, but with a critical twist. It's built on an open architecture that can access and work with data wherever it is, without forcing you to move it into a proprietary format. And finally, there's Watsons.governance. This is the crucial, often overlooked piece of the puzzle. It's a toolkit for managing AI responsibly, tracking where your models came from, what data they were trained on, whether they're biased, and how they're making decisions. For a regulated industry like finance or healthcare, this isn't a nice to have. It's a license to operate. To make all this work, IBM relies on a concept they call a data fabric. It sounds complex, but the idea is simple and powerful. Imagine stretching a smart virtual mesh over your entire, messy, complicated IT landscape. This fabric connects to your mainframe, your Oracle databases, your cloud storage, your IoT sensors, everything. Without moving a single byte of data, the fabric allows you to discover, catalog, and access all of it as if it were in one place. So now let's go back to our bank. With this approach, their data science team can use Watson AI to build their fraud detection model, using open-source tools like Python and TensorFlow. Through the data fabric, they can train that model on the live transaction data, right on the mainframe without ever making a risky copy. The model runs inside a secure container, managed by OpenShift, right next to the data source. It can spot fraud in milliseconds, not hours. The governance tools automatically log every step, creating a perfect audit trail for regulators. The bank gets the power of modern AI without compromising the security and reliability of its core systems. They didn't have to dynamite the foundation. They just built a new, smarter structure on top of it. This is why major airlines use IBM Cloud to modernize their decades-old reservation systems, which are some of the most complex software systems ever built. They can't just turn them off. Instead, they use this hybrid approach to build new AI-powered customer service tools that can talk directly to that core system, pulling flight data in real time. It's why healthcare providers use IBM to build diagnostic tools that analyze patient data stored in their on-premise, HIPAA-compliant servers, ensuring sensitive medical records are never exposed to the public internet. It's a strategy born from a deep understanding of how large, complex American companies actually work. They don't have the luxury of starting from a blank slate like a Silicon Valley startup. They have history, they have legacy, and that legacy contains their most valuable asset, their data. IBM's core value proposition isn't move to our cloud. It's we'll help you build a bridge from your past to your future, and we'll help you unlock the value of the data you already have, wherever it is. This approach of bringing computation to the data is a game changer. It's faster, it's cheaper, and it's inherently more secure. But it also raises an incredibly important question. When you start running powerful AI on your most sensitive, regulated, crown jewel data, the security protecting that interaction can't just be good. It has to be perfect. It has to be bulletproof. And that level of security, especially in a hybrid world, is one of the most difficult challenges in technology today. It requires a completely different way of thinking about protecting not just data, but the very computations themselves. This idea of protecting computation itself is not just a minor upgrade. It's a paradigm shift in cybersecurity. For decades, the industry has focused on two primary states of data: data at rest, which means your files sitting on a hard drive, and data in transit, which is your information flying across the internet. We have great solutions for these. Encryption protects your files on a disk, so if someone steals the physical server, they just get a block of unreadable gibberish. SSL and TLS protocols protect your data in transit, creating a secure tunnel for your credit card information when you buy something online. Think of it like a bank. Data at rest is the money locked inside the vault. Data in transit is the money being moved in a heavily armored truck. Both are secure. But there's a third critically vulnerable state that we've largely ignored: data in use. This is the moment the data is loaded into the computer's memory and processed by the CPU. In our bank analogy, this is the moment the banker takes the money out of the vault and out of the armored truck to count it on a table in the back room. At that precise moment, it's exposed. Anyone with high-level access to the system, a privileged administrator, a sophisticated hacker who has compromised the operating system, or even the cloud provider itself, could theoretically peek over the banker's shoulder and see everything. For most applications, the risk is manageable. But for a Fortune 500 company handling trade secrets, a hospital processing sensitive patient records, or a government agency analyzing classified intelligence, that brief moment of exposure is an unacceptable, catastrophic risk. This is the problem that IBM Cloud is obsessed with solving, and their answer is a technology called confidential computing. The concept is breathtakingly simple in its goal, but incredibly complex in its execution. What if you could build a secure, invisible room inside the processor itself? A digital black box, a secure enclave, where data can be processed in complete isolation. Data goes into the enclave encrypted. It's decrypted only inside this protected, sealed-off portion of the CPU's memory. The calculations are performed, and the result is encrypted again before it ever leaves the enclave. The revolutionary part is this: while the computation is happening, no one can see inside. Not the other applications running on the same server. Not the server's main operating system. Not a systems administrator with the highest level of root access. Not even the cloud provider IBM itself. It is a fundamentally private space, cryptographically sealed and verified. The hardware itself guarantees that only the authorized code is running on the authorized data. It's like the banker is no longer counting money in an open room, but is instead locked inside a smaller, impenetrable vault with no windows and no cameras, and only he has the key. He performs his work in total secrecy, and then passes the result back out through a secure slot. Now, why is this so critical for the major US companies that are IBM's bread and butter? Let's paint a picture. Imagine 3 of the largest, most competitive pharmaceutical companies in the United States. Each has decades of proprietary research and patient trial data, worth billions of dollars. They all want to collaborate to build a powerful AI model that can predict the early onset of a rare form of cancer. A model trained on their combined data would be exponentially more powerful than anything they could build alone. Could save thousands of lives. But they have a massive problem. They are fierce rivals. They would never, ever share their raw patient data with each other. It's their most valuable intellectual property. Furthermore, strict HIPAA regulations in the US make it a legal and compliance nightmare to pool this kind of sensitive information. The project seems impossible. The data is siloed, locked away in their respective vaults, and the potential for a world-changing medical breakthrough is stuck. This is where confidential computing on IBM Cloud becomes the key that unlocks the future. Here's how it works. All 3 companies agree to use a secure enclave in the IBM Cloud. Company A uploads its encrypted patient data. Company B does the same, and so does Company C. The AI training algorithm is also loaded into the secure enclave. Once inside that protected environment, the data from all 3 companies is decrypted. The AI model trains on this massive combined dataset, learning patterns it could never have seen from a single source. It becomes incredibly accurate. Once the training is complete, the final trained AI model, the valuable output, is encrypted and made available to the consortium. The raw data? It is destroyed, having never left the confines of the secure enclave. At no point did Company A see Company B's data. At no point did IBM see any of the data. The integrity of the process is guaranteed by the hardware. This isn't just a promise from a sales team. It's a mathematical and physical certainty built into the silicon. This single capability enables a level of collaboration between untrusting parties that was science fiction just a few years ago. Now replace pharmaceutical companies with banks collaborating on fraud detection without sharing customer transaction data. Or with automotive rivals sharing sensor data to train self-driving cars without revealing their proprietary engineering secrets. Or with government agencies sharing intelligence to thwart a threat without exposing their sources and methods. The possibilities are endless, and they all hinge on this foundation of computational trust. This commitment to confidential computing is a core reason why enterprises with incredibly high-stakes data gravitate towards IBM. It's not a feature they bolted on. It's an extension of a security philosophy they've been cultivating for over half a century with their mainframe systems. The IBM Z platform, the modern mainframe, has had concepts like workload isolation and secure execution for decades. It's in their DNA. They build the hardware, they write the firmware, they manage the virtualization layer, and they provide the cloud services on top. This full-stack control gives them a unique ability to integrate these deep security features in a way that's robust, audited, and reliable. For a chief information security officer at a major US bank, the choice isn't just about which cloud is cheapest or has the most features. It's about which cloud can provide a verifiable, auditable chain of custody for their most valuable digital assets. When they can go to their board of directors and say, "Our most critical financial modeling application runs in an environment so secure that not even the cloud provider's engineers can access it while it's running," that is a statement of profound confidence. It's a level of assurance that changes the entire risk conversation. It allows them to innovate faster, to adopt AI, and to collaborate in ways they couldn't before, all while maintaining a security posture that is, for all practical purposes, unbreakable. So we have this impenetrable fortress for our data and code. But how do you manage it all? How do you orchestrate these complex, secure workloads across a dozen different environments, some on-prem, some in the public cloud, some at the edge, without losing your mind? That's where the real operational magic comes in, and it's a story of control and automation at a scale that's hard to even imagine. This level of control is built on a single powerful idea that fundamentally changed the game for enterprise computing. It's an idea born from the open source world, nurtured by Google, and then supercharged for the enterprise by Red Hat, which IBM strategically acquired for a staggering $34 billion. That idea is Kubernetes, but the reality for IBM's clients is a platform called Red Hat OpenShift. And if you want to understand why a Fortune 500 company bets its future on IBM Cloud, you have to understand OpenShift. Imagine you're the chief technology officer of a major US airline. Your digital operations are a sprawling, complex beast. You have a massive, decades-old mainframe system in a data center in Dallas that handles flight reservations and ticketing. It's rock-solid, secure, and it cannot fail. You have a private cloud in a facility in Chicago running your crew scheduling and logistics software, built to your exact specifications for maximum performance. And you're using Microsoft Azure for your customer-facing website and mobile app, because you want to take advantage of its global scale and content delivery network to give travelers a fast, smooth booking experience. Now, a new federal regulation comes down. You have to update the baggage handling logic. But here's the catch. The baggage system has to talk to the reservation mainframe, the logistics private cloud, and the customer mobile app on Azure. In the old world, this is a heart-stoppingly complex project. You have 3 different teams of specialists: the mainframe veterans, the private cloud engineers, and the Azure public cloud experts. They all speak different technical languages. They use different tools. Deploying a change requires weeks of coordination, manual testing in separate environments, and a go-live weekend that involves dozens of people on conference calls, praying nothing breaks. The risk is immense. One tiny mistake could ground flights nationwide. This is the operational chaos that OpenShift was built to tame. Think of OpenShift not as a product, but as a universal operating system for the cloud. It creates a consistent, abstract layer that sits on top of all your different environments. It doesn't matter if the underlying hardware is a mainframe, a server in your own data center, or a virtual machine in Azure. To your developers, it all looks and feels the same. They are no longer writing an application for Azure or an application for the private cloud. They are writing an application for OpenShift. And OpenShift, the master orchestrator, figures out how to run it optimally and securely on any of those underlying platforms. It's like writing a novel in English and having a magical publisher who can instantly and perfectly translate it into any language, format it for any type of book or e-reader, and distribute it globally, all with the push of a single button. The author doesn't need to be an expert in Japanese typesetting or German bookbinding. They just focus on writing the best possible story. This is what OpenShift does for developers. It frees them from the tyranny of the underlying infrastructure. So let's go back to our airline. With OpenShift running across their hybrid environment, the entire baggage handling update becomes a different story. The developers package the new software logic into something called a container, a standardized, self-contained unit that has everything it needs to run. They define the entire application, how the container for the mobile app talks to the container for the logistics system, and how that talks to the mainframe API, in a single set of configuration files. This is infrastructure as code. The entire complex, multi-part system is described in a human-readable text file. They commit this new code to a repository. An automated system managed by OpenShift immediately kicks in. It builds the containers, runs thousands of automated security scans and performance tests in a simulated environment, and once everything passes, it's ready for deployment. The operations team doesn't have to manually log into dozens of servers. They issue a single command: deploy. OpenShift then performs a breathtakingly sophisticated digital ballet. It gracefully tells the old version of the baggage application to stop accepting new requests. It seamlessly spins up the new version on the mainframe, in the private cloud, and on Azure simultaneously. It reroutes traffic to the new version, constantly monitoring its health. If it detects even the slightest anomaly, a spike in errors, a drop in performance, it automatically and instantly rolls the entire system back to the previous stable version. No customer ever notices a thing. What used to be a month-long, high-risk manual ordeal is now a low-risk, fully automated 15-minute process. This isn't just an improvement, it is a complete paradigm shift. It's the difference between building a car by hand and running a fully automated Tesla Gigafactory. The speed, reliability, and scale are simply in a different universe. This level of automation and control is a competitive advantage, but for companies in regulated industries like banking, healthcare, and insurance, it's also about survival. This is where IBM's mastery of the enterprise shines brightest. Let's take a major health insurance provider. They are bound by HIPAA, the Health Insurance Portability and Accountability Act. A single data breach could result in fines totaling hundreds of millions of dollars and an irreparable loss of customer trust. Their challenge is proving compliance to auditors. How do you prove that every single one of your thousands of applications, scattered across your on-premise data centers and multiple public clouds, is configured correctly? That all data is encrypted? That only authorized personnel have access? Traditionally, this involves armies of auditors spending months manually checking server configurations and interviewing staff. It's slow, expensive, and prone to human error. With the IBM Cloud and Red Hat OpenShift, this process is transformed. Security isn't an afterthought. It's baked into the automated platform. You can define your corporate security policies as code. For example, a policy might state, all data storage must be encrypted with the AES-256 algorithm, and all network traffic between application components must use TLS 1.3. This policy is then automatically enforced by OpenShift across every environment. A developer can't accidentally deploy an application with weak encryption, because the platform simply won't allow it. It fails the automated checks. And when the auditors come, you don't give them a mountain of paperwork. You show them a dashboard. The IBM Cloud Security and Compliance Center provides a real-time view of your compliance posture across your entire hybrid cloud. It continuously scans everything and can generate a detailed audit report with a single click. It turns a 6-month manual audit into a 5-minute automated report. For a Chief Information Security Officer, this is the holy grail. It's proactive, automated, and continuous compliance, managed from a single pane of glass. This is a capability that general-purpose public clouds are still struggling to match for these complex, hybrid enterprise environments. But IBM pushes this concept of run anything, anywhere even further to the very edge of the network. What if you're a car manufacturer with a factory in Michigan? You need immense computing power on the factory floor to run AI models for quality control, analyzing video feeds from the assembly line in real time. Sending all that video data to a public cloud introduces latency. The delay is too long. The computation has to happen right there. Or what if you're a retail chain and you want to run the same modern, cloud-native point-of-sale and inventory management software in all 500 of your stores, some of which have spotty internet connections? This is the problem that IBM Cloud Satellite solves. It allows a company to create a secure, managed IBM Cloud location anywhere they have infrastructure. You can install satellite on the servers in your factory, in your retail store, or even on an oil rig in the middle of the ocean. This location then becomes a managed endpoint of the central IBM Cloud. You can deploy and manage applications to your factory floor using the exact same OpenShift tools, the same security policies, and the same automation you use for your public and private clouds. It's a single unified development and operations experience, from the core of your data center to the farthest edge of your enterprise. This unified management fabric powered by OpenShift, secured by the Compliance Center and extended by satellite, is the operational backbone that major U.S. companies rely on. It's how they tame the complexity of the modern digital world. It allows them to innovate at the speed of a startup, while maintaining the security and reliability of a blue-chip enterprise. But managing the infrastructure is only half the battle. Once you have this incredible, unified platform, what do you do with it? You unleash the most powerful force in technology today, artificial intelligence. And how IBM integrates its legendary AI Watson into this hybrid cloud fabric. Well, that's where the game truly changes. This isn't the Watson that won Jeopardy over a decade ago. That was a brilliant proof of concept, a coming out party for what natural language processing could do. But today, Watson isn't a single entity. It's not a know-it-all in a box. It's a powerful suite of enterprise-grade AI tools, services, and models designed for one purpose: to solve the gnarliest, most complex problems in business. And the way it does this is by living on the hybrid cloud, which gives it a superpower that other AI platforms can only dream of. Think about the biggest challenge for any AI: data. AI is ravenously hungry for data. The more high-quality data it has, the smarter and more accurate it becomes. Now, where does a major US bank, a top-tier hospital, or a global airline keep its most valuable, most sensitive, most mission-critical data? Is it all neatly packaged and sitting in one public cloud? Absolutely not. It's a mess. Decades of transaction records are sitting on a mainframe in a New Jersey data center. Patient health records are locked down on-premise to comply with HIPAA. Customer data is split between a Salesforce cloud and an Oracle database. This data is scattered, siloed, and often, for very good security or regulatory reasons, it cannot be moved. This is what we call data gravity. The data is so massive and so important that it's easier to bring the processing to the data than it is to move the data to the processing. And this is where the genius of IBM's strategy clicks into place. Most cloud providers tell you, to use our fancy AI, you have to move all your precious data onto our cloud. For many large companies, that's a non-starter. It's too risky, too expensive, and sometimes legally impossible. IBM, with its hybrid cloud architecture built on Red Hat OpenShift, says the exact opposite. They say, don't move your data. We'll bring Watson to you. Because Watson is containerized and runs on OpenShift, it can be deployed anywhere. On-premise, in a private cloud, on AWS, on Azure, on Google Cloud, even at the edge in a factory or a retail store. Watson becomes a world-class traveling consultant that can securely show up right where your data lives, do its work, and provide insights without ever forcing you to expose that sensitive information to the public internet. It's the ultimate house call for your data. Let's make this real. Imagine a major American insurance company. They want to use AI to speed up claims processing. The claim photo submitted by a customer is on a public cloud object store. The customer's policy information is in an on-premise database. The adjuster's notes are in a third-party SaaS application. Using IBM's hybrid cloud, they can deploy a Watson AI model that accesses all three sources of data, right where they are. It analyzes the photo for damage, cross-references the policy details to check for coverage, and uses natural language processing to understand the adjuster's notes, all in a single, automated workflow. The result? A claim that used to take days of manual work is now approved in minutes, securely and accurately, without ever having to consolidate that data into one vulnerable location. That's not a futuristic concept, that's happening right now. Or take a manufacturer. They have sensors on their assembly line generating terabytes of operational data, which is stored locally for real-time access. They want to use AI to predict when a machine will fail before it happens. They can deploy a Watson model right there, at the edge inside the factory. The AI analyzes the sensor data in real time, spots a microscopic deviation in vibration, and alerts the maintenance crew to replace a bearing that was 3 hours away from catastrophic failure. They just prevented a 6-figure shutdown and a week of lost production. The AI didn't need to send a flood of data to a distant cloud. It worked right where it was needed most. This run-anywhere AI capability has now evolved into IBM's flagship platform, Watsonx. If Watson was the collection of tools, Watsonx is the state-of-the-art integrated workshop. It's built around 3 core components that every major company is now scrambling to get right. First, there's WatsonX.ai. This is the studio for building AI. It's where data scientists and developers can use IBM's own powerful foundation models, the same kind of tech behind tools like ChatGPT, but also open-source models from places like Hugging Face. The key difference is, they can train and fine-tune these models securely on their own private company data. They're not just using a generic public model. They're creating a bespoke AI that understands the specific language of their industry, their company's products, and their unique business processes. Second, there's Watsonx.data. This is the solution to the scattered data problem we talked about. It's a data lakehouse, a modern architecture that lets you connect to and query all your data, whether it's in a mainframe, a data warehouse, or another cloud, as if it were all in one place. It's like having a universal remote for your entire company's data landscape. You don't have to move it or copy it. Watsonx.data finds it, connects to it, and makes it available to the AI models in WatsonX.ai. This single component can save companies millions in data migration and duplication costs. And third, and this might be the most important piece for American corporations, there's Watsonx.governance. In a world increasingly terrified of AI bias, hallucinations, and a lack of transparency, governance is the answer. This is a toolkit for managing AI risk and ensuring compliance. It automatically tracks where a model's training data came from, it detects and mitigates bias in its outputs, and it can explain why the AI made a particular decision. For a bank using AI to approve or deny loans, or a hospital using AI to suggest a diagnosis, this isn't optional. It is the absolute requirement for deploying AI responsibly and avoiding massive regulatory fines and reputational damage. It's the difference between using powerful, wild magic and practicing precision, industrial-grade engineering. So you see, the story isn't just IBM has AI. The story is that IBM has created an integrated platform, Watson, that lets companies build, scale, and crucially govern their own AI using their own data wherever that data happens to live. It's built on a hybrid cloud foundation, meaning the entire workshop, the AI studio, the data access, the governance toolkit, can be set up in their own secure data center, on their preferred public cloud, or across a mix of both. It gives them the power of cutting-edge AI without forcing them to give up control over their most valuable asset, their data. This combination of power and control is why you see IBM's logo in the annual reports of the biggest names in finance, healthcare, and retail. But this raises a fascinating and critical question. If the whole point of this strategy is that Watson and the Watson platform can run anywhere, on AWS, on Azure, on-premise, then why does IBM even need its own public cloud? If the software is the star of the show, what unique, compelling advantage does running it on IBM's own cloud infrastructure actually provide? What is the secret weapon that makes their own cloud the best place to run their own AI? That piece of the puzzle is the key to understanding the entire IBM ecosystem. The answer lies not in a single piece of software, but in the very foundation of the cloud itself, the metal. The secret weapon is IBM's deep, almost obsessive vertical integration of its own custom-designed hardware with its own powerful software. To truly grasp this, we have to talk about something most cloud discussions completely ignore: the processor architecture. While Amazon, Google, and Microsoft have built their empires on the x86 architecture, the chips designed by Intel and AMD that power virtually every laptop, desktop, and server you've ever used, IBM plays a different game. A significant portion of the high-performance infrastructure underpinning IBM Cloud, especially for AI and mission-critical workloads, runs on their own proprietary architecture, IBM Power. Think of it this way: the x86 architecture is like a Ford F-150. It's incredibly versatile, popular, and great for a huge variety of jobs. It's the undisputed king of the road for general-purpose computing. But IBM Power architecture isn't an F-150. It's a specialized 18-wheel freightliner designed from the ground up to do one thing better than almost anyone else: haul massive amounts of data at incredible speeds with rock-solid reliability. This isn't just a branding difference. The physical design of the chips is fundamentally distinct. Power processors like the new Power 10 are built with a much wider data bus. Imagine the connection between the processor and the memory as a highway. An x86 processor might have a solid 8-lane highway. It's fast and efficient. But a power processor is designed with a 16-lane superhighway. For tasks like training an AI model, where you are constantly moving colossal datasets back and forth, having twice the number of lanes means you eliminate traffic jams. The data just flows unimpeded. This translates directly into faster model training and quicker insights. It also boasts superior memory bandwidth. If the data bus is the number of lanes on the highway, memory bandwidth is the speed limit. IBM's Power architecture allows for significantly higher speed limits, meaning data can be shuttled between the system's memory and the processor cores at blistering speeds. When your AI model has billions of parameters, this isn't a luxury. It's a necessity. It's the difference between a calculation taking hours versus days. Now here's where it all connects back to Watson. Watson isn't just a piece of software that IBM happens to sell. It was born and raised on Power architecture. The engineers who wrote the code for Watson had intimate knowledge of the hardware it was going to run on. They could write software that took advantage of every single unique feature of the Power processor, every extra lane on that data highway, every extra mile per hour on the speed limit. This is IBM's version of the Apple ecosystem advantage. Apple designs its own A-series and M-series chips, and they design their own software, iOS and macOS. The result is a seamless, hyper-efficient experience that competitors using generic hardware struggle to replicate. IBM is doing the exact same thing, but for enterprise-grade artificial intelligence. Running Watson on IBM Cloud with Power systems is like running iOS on an iPhone. Just works better. It's faster, more efficient, and more stable because the software was tailor-made for the hardware, and the hardware was built to make the software sing. When a major US bank decides to run Watson on another cloud provider, they're essentially running this finely tuned software on generic third-party hardware. It's like trying to run macOS on a Dell laptop. You can get it to work, but it will never be as smooth, as fast, or as reliable as running it on a MacBook. IBM's home field advantage is that they control the entire stack, from the silicon in the processor all the way up to the AI application interface. But the secret weapon is even bigger than just the chip. It's about the entire integrated system. Remember Red Hat OpenShift, the containerization platform we talked about? IBM has invested billions to ensure that OpenShift is not just compatible with, but deeply optimized for, their power systems. This creates a perfect high-performance foundation. So now you have a custom-built Freightliner of a processor, running a custom-tuned operating system, all designed to support the flagship AI platform. And it goes deeper. IBM Cloud's infrastructure includes its own high-performance storage solutions, like IBM Spectrum Scale, a file system designed for handling the massive data requirements of AI and high-performance computing. It's all connected with a high-speed, low-latency networking fabric. The result is a complete, end-to-end ecosystem where every single component has been engineered to work in concert, eliminating the bottlenecks you find when you're piecing together solutions from a dozen different vendors. So, why does a CEO or a CTO of a major American company care about any of this? 3 reasons: performance, security, and gravity. First, performance. For these massive corporations, training a new AI model for fraud detection or supply chain optimization can cost millions of dollars in compute time. If IBM's integrated stack can train that model 20% or 30% faster, that translates into millions of dollars saved and getting a critical business advantage weeks or even months ahead of the competition. It's a simple, brutal calculation of time and money. Second, security and reliability. When you control the entire stack from the chip to the code, you can build security in at every single layer. The Power 10 chip, for example, has features like transparent memory encryption, meaning data is encrypted while in transit and in use, a level of security that is incredibly difficult to achieve in a mixed vendor environment. For a hospital handling patient data or a bank processing financial transactions, this integrated, verifiable security isn't just a feature, it's a license to operate. And when something goes wrong, there is one company to call, one throat to choke. There's no finger pointing between the hardware vendor, the operating system provider, and the application developer. It's all IBM. Finally, and perhaps most importantly, is data gravity. Many of these Fortune 500 companies, the ones that have been around for decades, already have the crown jewels of their data sitting on IBM systems, specifically the legendary IBM Z mainframe. The mainframe is the ultimate system of record for the global economy, processing an insane percentage of the world's credit card transactions, airline bookings, and stock trades. IBM's masterstroke is creating a seamless and secure hybrid cloud bridge between these mainframes and their power-based AI cloud. A bank doesn't have to undertake a risky, multi-year, billion-dollar project to move its core transaction data to the cloud. Instead, they can keep the data right where it is on the ultra-secure mainframe and use Watson's running on IBM Cloud to analyze that data in real time. This is a capability that no other cloud provider can even come close to offering. They are allowing companies to bring cutting-edge AI to their most valuable data without ever having to move it. So the secret weapon isn't just a faster chip or a clever piece of software. It's a holistic, vertically integrated strategy that combines proprietary high-performance hardware, optimized open-source software, and a deep understanding of the legacy systems that still run the world's economy. It's a fortress built to serve the most demanding, most regulated, and most valuable customers on the planet. Now that we understand the technology, the customers, and the hidden strategic advantage, one final question remains. In a world increasingly dominated by the sheer scale and marketing power of the hyperscalers, is this specialized, integrated approach a brilliant long-term strategy, or the last stand of a bygone era? What does the future truly hold for IBM Cloud? To answer that, we have to fundamentally shift our perspective. If you judge IBM Cloud by the same metrics as Amazon Web Services or Microsoft Azure, things like raw market share in public cloud infrastructure, then the last stand argument seems plausible. They are, by that measure, a distant third. But that's like judging a submarine by its ability to fly. It completely misses the point of what it was designed to do. The truth is, IBM isn't playing the same game. While the hyperscalers were in a race to build the biggest and cheapest digital landlord, renting out virtual real estate on a massive scale, IBM was quietly building something different. They were building the ultimate digital property manager for a world that was inevitably going to have real estate everywhere. This isn't a retreat. It's a strategic repositioning. It's a bet, a massive multi-billion-dollar bet, that the future of enterprise IT isn't one cloud but many. It's a bet that the biggest challenge for the world's most important companies won't be moving to the cloud, but managing the inescapable complexity of being on-premise on a private cloud on AWS, on Azure, and on Google Cloud all at the same time. This is the messy, complicated reality that doesn't make for a splashy Super Bowl ad. And this is where IBM's strategy transforms from a last stand into a stroke of genius. Think about it. The acquisition of Red Hat for $34 billion wasn't about buying a cloud company. It was about buying the digital equivalent of the Geneva Convention, a neutral, respected standard that could operate across all territories. Red Hat OpenShift is the key that unlocks this entire strategy. It's the universal translator, the common operating system for the multi-cloud era. It allows a company like American Airlines or Bank of America to build an application once and deploy it anywhere, on their own mainframe, in an IBM Cloud data center for security, or on Azure for its AI services, without rewriting the entire thing. It turns the cloud from a set of competing kingdoms into a federated republic, with IBM providing the constitution. This is why major companies stick with them. They aren't just buying cloud services, they're buying coherence. They're buying a solution to a migraine-inducing problem that the hyperscalers, by their very nature, helped create. When your business runs on a 40-year-old mainframe system that is still faster and more secure for processing transactions than anything in the public cloud, you don't call Amazon. You call the one company on Earth that understands how to seamlessly connect that mainframe to a modern, containerized application running in a data center in Frankfurt. When you're a bank operating under a mountain of regulations, you don't just want a generic security product. You want the IBM Cloud for financial services, a platform co-designed with Bank of America, pre-configured to meet those exact, punishing compliance standards. This is the core of the strategy. It's not about being the best at everything, but about being the indispensable integrator of everything. IBM's value proposition isn't move all your stuff to our cloud. It's wherever your stuff is and wherever it needs to go, we will provide the secure, manageable, and compliant fabric to connect it all. It's a less glamorous but, for a certain class of customer, an infinitely more valuable promise. But this strategy of integration and specialization is only half the story. The other half is what's coming next. Because while IBM is solving the problems of today's complex IT world, it's also laying the groundwork for the computing paradigm of tomorrow. And that brings us to the elephant in the room, or rather, the chandelier in the supercooled chamber: quantum computing. For years, quantum has been the stuff of science fiction, a theoretical concept that was always 20 years away. But it's not anymore. Right now, on the IBM Cloud, developers, researchers, and corporations can log in and run algorithms on a real functioning quantum computer. IBM has put the most advanced quantum hardware in the world on its cloud, accessible to anyone with an internet connection. This isn't a side project. It's a fundamental pillar of their future. While other companies are fighting over who has the fastest virtual machine, IBM is in a race to build a machine that can solve problems that are literally impossible for any classical computer to solve, no matter how powerful. Think about the implications. For pharmaceutical companies, it means designing new life-saving drugs at a molecular level. For financial institutions, it means creating risk models of such complexity that they could potentially foresee and prevent the next global financial crisis. For materials science, it's about discovering new compounds for batteries that could revolutionize the energy sector. These are the unsolvable problems, and IBM's bet is that the first companies to solve them will do so through their cloud. This move completely reframes IBM's identity. It positions them not as a company catching up to the last technological wave, but as the company building the vessel for the next one. The cloud is no longer just a place to run your websites. It becomes the exclusive gateway to an entirely new form of computation. And alongside quantum is their renewed focus on artificial intelligence with Watson. After the initial hype of Watson on Jeopardy, IBM has refocused its AI strategy away from flashy stunts and towards the core of its enterprise base. The goal of Watson isn't to create the most creative chatbot. It's to help a bank build an AI model to detect fraud that is transparent, explainable, and auditable, so they can prove to regulators exactly how it works. It's to help a manufacturer use AI to predict maintenance on its factory floor, running on their own data, inside their own secure environment. It's AI for the real, regulated, high-stakes world. It's about governance and trust, not just capabilities. And where does this trusted AI run? On their hybrid cloud platform, of course, allowing companies to train models on sensitive data stored on-premise and then deploy them in the cloud, all managed by that same Red Hat fabric. So, when we pull back and look at the entire picture, the answer becomes clear. Major US companies don't use IBM Cloud because it's the trendiest or the cheapest option. They use it because it represents a deliberate strategic choice. They choose it for integration in a world of fragmentation. They choose it for its deep, almost obsessive focus on the security and compliance needs of their specific industries. They choose it because IBM understands their legacy systems better than anyone and provides a practical evolutionary path to modernize them, rather than a revolutionary high-risk demand to replace them. They are choosing a partner that helps them manage the messy reality of today, while simultaneously giving them a front-row seat to the computational revolution of tomorrow with quantum. IBM isn't trying to win the cloud war. They are positioning themselves to be the indispensable arms dealer, diplomat, and technology pioneer for all sides. It's a strategy built not on scale alone, but on specialization, integration, and a long-term vision. So the question was never really whether IBM Cloud could beat AWS. The real question is, as the digital world becomes more complex, more distributed, more regulated, and more reliant on specialized computing, is the IBM approach of being the master integrator, the trusted shepherd for a multi-cloud, quantum-powered future, not just a viable strategy, but an increasingly essential one. For the companies that run our world, the ones where the cost of failure is measured not in dollars, but in public trust and national security, the answer appears to be a resounding yes.